hi guys. Hope you're ready to learn something new. No more graphing for a little while. We're going to work on trigonometric identities. This sheet you're looking at, if you have the unit circle from class, it is printed on the back of your unit circle. If you can't find that, I did upload one to the resources on my focus page. So the only identities we are going to be looking at this week and probably next week or so, but at least this week I know for sure, I haven't looked that far ahead, are just these first ones here. The reciprocal identities and the Pythagorean identities. Okay? You are 100% already familiar with all these reciprocal identities. We know that sine is the reciprocal of 1 over cosecant. You know cosine is this. Just look over them. We have learned these probably since January. We probably haven't talked about tangent being sine over cosine. But if you think about tangent, we know tangent is y over x. And we know sine is usually represented by y and cosine is represented by x. So maybe we hadn't put it in those terms, but we 100% have learned that. Then the other thing I want to quickly point out before I get into the problems is that these top 3 Pythagorean identities are the ones that are the identities. If you look at these 2 underneath here, those are just manipulated, meaning from here to here, all they did was move the cosine over, subtracted it. And for the third one here, they just moved the sine over. Same thing with these 2 and the same thing with these 2. They just manipulated that first formula to see it in all 3 ways. Sometimes that'll help us to notice things that are happening, and that's why I wanted you to have this sheet. Okay. All right, so I'm going to keep this out beside me. It is honestly sitting here on my table. I don't want to try to keep flipping back and forth because that'll take a lot of time, but you need to have this sheet in front of you as well. So now we're going to go through, now we're going to go start with simplifying these trig expressions. Okay? Now, these are probably a little different than anything you've done. A first good step in simplifying your expression is changing anything you can to sine and cosine. All right? Again, we're only looking at the reciprocal identities and Pythagorean identities. And most of today, probably just reciprocal ones, maybe one of the Pythagoreans. So this is already cosine. This is already sine. We're not going to change that. But we can change tangent. Look at your reciprocal identities. In fact, it's the one I just pointed out. We can rewrite tangent as sine over cosine. So here we go. We're going to keep the cosine of t plus tangent we're going to change to sine of t over cosine t, still times the sine of t. And I should have written that over farther. I guess I'll write it over here. I'm going to write for today why we did what step we did. We did this step because we changed tangent to sine over cosine using a reciprocal identity. And that's why I wrote that right there. All right? Again, we're trying to make our problem simpler every step of the way. So what do you think we need to do in the next step? What do you see happen on the right-hand side over here? Well, let's do some multiplication. You got it. We're simply going to multiply. So we got cosine of t plus sine times sine gives me sine squared t. Make sure it's on the sine and not the t. There's a difference. Remember, t represents an angle over the cosine of t. Because cosine times 1 is just cosine. All right. How do you add fractions? you have to get a common denominator. And so our common denominator would be cosine t. It's all we got. Okay, so cosine of t is our new denominator. Now, what is this cosine on the left-hand side over? It's a whole, so remember it's over 1. So we need to make this have a common denominator of cosine t. So what is 1 times what gives me cosine t? Well, cosine t. And remember that rule, whatever you do to the bottom, you got to do the top. So the top we have to multiply by cosine t also. And cosine t times cosine t, for this guy, changes it to cosine squared t. And the sine squared already had cosine t as its denominator, so we just keep the numerator. Now, already our first Pythagorean identity. Look at the very first one in the very first column. Is sine squared a plus cosine squared a the same thing as cosine squared t plus sine squared t? Yes. Remember that t and the a represent angles. So, remember our goal is to make it simpler. Instead of cosine t and sine t, we're going to make that equal to 1 because of our Pythagorean identity. So now we have 1 over cosine t. Do you think a fraction is as simple as it can get? What do we know pairs with cosine? Secant. Look at your reciprocal identities. What's written there for secant? Okay, we see that secant is equal to 1 over cosine. So in simplest form, this is secant t. One of the hardest things I know in teaching this topic is knowing when you're done. A good way to know when you're done is what else can you do to secant t? Is there anything else you can do to make it simpler? Right? The only thing I see under my reciprocal identities is to go back to what we had up here. And that's going backwards. That's not making it simpler. A fraction is not simpler than a non-fraction. These take practice. Let's move on. So our next, remember a first good strategy is to change anything you can to sine or cosine. Okay, so do we know anything about secant? I'm just looking at my reciprocal identities. I see that it could be written as 1 over cosine. So sine of theta, remember it's just an angle, doesn't matter, would be multiplied by 1 over cosine plus cosine theta. Do we see anything about cosecant? I see it's 1 over sine. I'm just getting these from my reciprocal identities. And again, I'm going to write the reasons over here for today so we can make sure we know why. A first good strategy, change anything and everything you can to sine or cosine. All right, now let's just multiply. We can't add until we multiply. So sine times 1 gives me sine. And 1 times cosine gives me cosine. Cosine times 1 gives me cosine. And 1 time, make sure you're putting your angle on there too. Don't just write sine over cosine, cosine over sine. All right, how do we add fractions? Common denominator. So remember, for your common denominator, take 1 of everything. So I'm going to take a cosine theta. And I'm going to take a sine theta. Now ask yourselves what's missing. Looking at my fraction on the left, cosine times what would give me my new denominator of cosine sine? I'm missing a sine, so I have to do sine theta that's existing times another sine theta that was missing, plus, looking at my fraction on the right, I have sine theta times what gives me cosine theta sine theta. I see what's missing is the cosine theta, so cosine theta times cosine theta. All I'm doing is making that common denominator. Okay, all right, clean it up a little bit. Sine times sine, sine squared theta, plus cosine times cosine, cosine squared theta. I didn't do anything with the denominator, so it stays the same. So all I did in this one was multiply again. Look at that numerator. Sine squared plus cosine squared. We just used that. It's your first Pythagorean identity. What do we know that sine squared theta plus cosine squared theta equals? Yep, 1. So that's a Pythagorean identity. So now we have 1 over cosine theta sine theta. Almost out of space. Okay. Do we see anything about 1 over cosine and 1 over sine in our reciprocal identities? Well, not together, right? Is it okay if I still write 1 over cosine theta times 1 over sine theta? Is that the same? It is. Multiply it back out. Okay. So I don't know what you want to call that. I call it like separate it or break it down. Okay. Now, what do we know about 1 over cosine? 1 over cosine is secant. What do we know about 1 over sine? 1 over sine is cosecant. And why was that? Our reciprocal identities. I can't spell. That's wrong. Reciprocal identity. Can we do anything to make secant simpler or cosecant simpler? Nope. When you have nothing else that'll make your problem simpler, that's when you know you're done. Like I said, these take practice. I know they're different. All right. A couple more. All right. So now we have some subtracting going on in the bottom. That's okay. A first good strategy is to change everything to cosine and sine. So what do we know about cotangent? Cotangent, I'm looking at my reciprocal identities. Cotangent is 1 over tangent, and cosine over sine. What do we know about cosecant? Cosecant, reciprocal identity is 1 over sine. So all we did there was reciprocal identity. Okay. Can we clean up the bottom? It already has a common denominator in the bottom, right? So either combine, if you want to call it, or make that common denominator. So it's still 1 over my common denominator of sine x. And that's cosine x minus 1. Make sure you realize that this was my true fraction, right? Okay. How can I get rid of a complex fraction? Right? It's a fraction and a fraction, it's called. How do you divide fractions? Keep, change, and flip. Or K, C, F. Not KFC, KCF. So 1 times